Hello, in this video we're going to go over a problem from the University of Maryland High School Math Competition Part 1. This is a competition that I run every October. A gambler comes to the casino with $2. He will leave the casino when he has $4 or when he is broke, whichever happens sooner. He can bet $1 at a time, either winning or losing a dollar. If the probability of winning each round is 40%, what is the probability that he will leave with $4? So this is one of those instances of a state problem. So he comes to the casino with $2. Then the next round he would end up with $1 or $3. The next round he would end up with either $0 or $2. So he would go back to this one, and then from 3 he would either end up with $4, which would mean he's done, or he ends up back at $2. So this is basically the state situation that we have for this gambler. So here is now what we were trying to figure out. We're trying to figure out what is the probability that he wins $4 when he starts with $2. Let's say the probability is P. Let's say the probability of 1 is Q, meaning that if he starts with $1, he ends up winning $4. And let's say the probability that he ends up with $4 when he starts with $3 is R. So what is the probability P? In the next round, he either loses a dollar or he wins a dollar. So the probability of losing a dollar is 3/5, and the probability of winning $4 when he starts with $1 would be Q. Or he wins this round, the probability is 40% or 2/5, and then starting from $3, he wins with probability of R. Now we'll do the same thing for Q. We get a system of equations and then we will solve. So what is the probability Q? Well, he either wins a dollar, the probability is 2/5, and then he ends up with $2, or he loses, the probability of that is 3/5, but then the chance of him winning is 0, of course. Now, if he starts with $3, either he wins a dollar, so the probability of that is 2/5, and the chance of that, the chance of him winning $4 is exactly 1, because he goes from $3 to $4. Or he loses a dollar, the probability of that is 3/5, and he ends up at the situation with $2. So this is a system of equations that we have to solve, and what we need is P. So here we can get Q. Q is 2/5 of P, and then we can take this one, plug it into the first one, we get P equals 3/5 times 2/5 of P plus 2/5 R, and then that gives us P equals 6/25P plus 2/5, and I also have R. R is 2/5 plus 3/5 P. So let's simplify that. That's 6/25 plus 4/25 plus 6/25P. And if you clear the denominators, we get 25P equals 12P plus 4. So we get 13P equals 4, which means P is equal to 4/13. So the answer to the problem is 4/13.